Guys, Firewall again. In this video we are going to see very exciting stuff from the firewall world and very exciting terms and definitions, and the important points when you do the troubleshooting. What are the things you need to consider, what things you need to keep in mind, what approach I usually use to deliver the troubleshooting. All those things we are going to learn today, and you have to be with me till the end of this video so you will understand what should be the right approach to deliver the work. That is one thing what we're going to deliver. The second thing, we will understand the important terms in a networking world, in specifically in the firewall world, like stateful packet inspection, what is packet filtering, how the stateful packet inspection works, how the packet filtering things come into the picture, then how the stateful packet inspection was developed, what was the purpose, and how you can use those terminology in real world here to deliver the work. Then we will see the troubleshooting approach, the TCP/IP OSI layer model. Will we understand like how I do the troubleshooting while I get any problem, what are the things I consider, what I give a thought to deliver that work. So be with me. So let's start basically with the term. Generally we hear quite a time when we deal with the firewalling or networking world. It's like, what is packet filtering? So as if you see on my screen, consider you have a firewall which is considered, for now it's a packet filtering firewall. It's just filtering the packets, right? Filtering. So consider whenever the packet comes from the internet or from the inside world, consider this is your external world, this is your internal world, where you have your say LAN segment and this is your WAN segment. All right, so whenever the packet comes from say outside world or go from the inside world, how the packet filtering works. So consider, say the packet comes like this, there's a P1 coming, it hit to the firewall interface here, and the firewall policy, how firewall works, you have a set of rules here to check this packet. Okay, so consider the packet, the P1 packet, you have some here say source IP address, destination IP address, source port, destination port, okay, and whatever the rest of the field like a sequence number. So based on this source IP address, destination IP address, source port, destination port, the rule what we have set up into the firewall is get matched, and based on that the packet is allowed. So in terms of the packet filtering firewall, these rules should be like for one side of communication. So consider the packet is coming from the internet, so like this, there's a one side of communication, you have a source IP address, destination IP address, source port, destination port, right? So that need to be allowed specifically here. So my rule will be look like, consider the rule number 1 2 3 4 5. Out of this, the rule number 1 will be the source is your source IP address, destination is the destination IP address which is defined into this packet, source port and destination port will be there. Okay, so whatever the packet will come from the outside world, only that packet will match this definition in this rule will allow. Okay, but in packet filtering firewall, consider the one-way communication will happen, because you only have the one rule place at a time for the one sort of traffic with the source destination what I have defined. But consider if you want to allow this packet to go outside as well, for example coming from the one direction and the packet need to be go to the other direction, I mean the reverse packet. So for that packet also you need to have that rule defined. So this will be the rule number 1, and the rule number 2 will be look like here. The destination was at the rule number 1 will be the source. So here the source will come like your destination, then your destination will come like a source, and the port also shuffle here. So you have to define these things in your rule. For example, in packet filtering firewall, for one packet communication you need to have two rules. So for say from source to destination you need to have rule 1 consider, and then from destination to source you need to have one rule. Okay, say consider rule number 2. In that situation only that packet will pass bi-directionally from, for example, the source and the destination communication, whatever we are going to specify will happen. In another word, let's understand this thing in a simplified way. So this is what the overview of the packet filtering, like how the packet filtering looks and works. Now just we will see how we can understand this thing using the consider TCP/IP. Sorry, consider using the handshake process. So let me just clear up my screen real quick. So just bear with me. Let's understand TCP/IP three-way handshake. So in any TCP/IP three-way handshake you will have your client machine and you will be having your server machine. Okay, here you can say this is your web server and this you can consider is your local machine. So what happens in a TCP three-way handshake? Three packets get exchanged. The client send the hello packet to the server. Server responds to that hello packet with the acknowledgement, and then client acknowledge to that packet that okay, now we can start the communication. Okay, this is what the basic three-way handshake process happens. So consider in the same way if I place some firewall here, okay, in between, consider there is a firewall here, say firewall. So how the communication will happen? So first packet need to be there for the one way of communication, say doing the hello communication. So the packet 1 is going from the client to the server here, right? So this is a packet 1. So in packet filtering firewall you need to have one rule for this communication. For say client is your source and server is your destination, you need to have a one rule in place for that communication. Likewise, when server want to acknowledge like this, you need to have the another rule into the firewall from the server to client. So the rule number 2, consider the packet 2 here. Okay, so this is what I was talking about. In a packet filtering firewall you need to have a two rule for one communication, right? So this was approach earlier when the stateful packet inspection processing was not there. This approach used to be used. Later on they have realized having this approach, the firewalls throughput of processing the rules is getting increased, the processing power is getting increased, and you need to have a multiple rules to configure there to have this communication in place. To get rid of this approach, they come up with the technique, they call it stateful packet inspection. So just let me clear up the screen real quick and then we'll discuss about the stateful packet inspection. So in stateful packet inspection what happens, Consider this is your firewall. Same example we are going to take. This is your internet and there is some LAN client machine. So consider the packet is coming from the internet to your machine. What will happen? Or whenever you define any particular rule into the firewall, but consider this time this firewall is a stateful, right? And now we are talking about the stateful packet inspection. The packet inspection happen statefully. So whenever packet will come to the firewall, you need to have only one rule. So this rule will be having your source IP address. So consider it has a multiple rules, and the rule number one what we are talking about. So it will have a source IP, destination IP, source port, destination port, and whatever the action you're going to allow, or a sequence number, whatever it is. So this will serve the purpose here. How? So whenever packet hit to this the P1 packet will hit to this firewall, firewall check whether this rule is there. So you will find source IP, destination IP, source port, destination port, whatever for this communication is already there. So what firewall will do? Firewall capture this information into their internal table. In different firewalls they have a different terminologies. So checkpoint firewall they call it like a kernel table. In Cisco world they call it like some sort of state table. Okay, so they will capture this information inside their, for now we'll consider like a state table, and the information will be captured like source IP, destination IP, source port, destination port, and what protocol is coming up. So these 5 tuples we can call is captured into the state table of the firewall. Okay, consider this is your state table, and this information is already captured here. So whenever the packet want to go to the internet, say for example P1, and it has a written packet for the same communication. So P1 want to reach to the internet, the same communication. What will happen? Instead of it checking the rules, it will check this state table whether that packet information is present into the state table or not. So if this information found in this state table, based on the state table information the communication will allow, and you don't have to have a second rule here for the reverse or return communication. So that rule processing and that rules burden is get reduced here, and based on this information this packet is get allowed. There is no rule to there is no need to have the second rule in place, and that is the basic fundamental behind the stateful inspection. So the rule setup get reduced, rule configuration get reduced, the processing here also get reduced, because the firewall just have to check this state table, and based on that state table details he need to allow the communication. Okay, and that's where the communication get passed from the firewall, and this communication get allowed. In variety of the scenario these things get worked. For example, if you have say big setup, you have multiple rules in place, and that time you need to deliver this work, this will help. Again, you have a VPN, you have a IPS configure, you have a URL filtering configure, whatever things is configured. This approach helps a lot to get help and get rid of the burden of the extra rules. I hope the stateful inspection fundamental or stateful packet filtering firewall fundamental is get clear, and the packet filtering also get clear. Let's quickly compare these two things, and then we'll go to the next topic. So let me clear up my screen real quick. So consider this is your stateful, and this is your the without stateful simple packet filtering firewall. Okay, what is the benefit? Number one, packet filtering is easy to configure. Okay, and setup, but takes manual effort. Whereas in stateful packet inspection, it's easy to configure, less manual effort, plus less CPU and memory processing. Here the CPU and memory processing is high, right? This is the main fundamental, and the admin role and admin work is get reduced here, right? And the fundamentals what we have explained, only one rule needed in stateful packet inspection to configure. In packet filtering you need to have at least two rules to allow that particular communication. Okay, processing is slow here, packet filtering slowness, and here you have a fast processing, right? Based on my description of this terminology, you can derive a lot of points and which are truly valid. Generally, whenever you go to the any networking interview, you generally get the question on this: what is stateful packet inspection? What is packet filtering? And what is difference between the packet filtering and the stateful packet inspection? Firewall give us the fundamental behind what is stateful and stateless, right? All this you can give the answer on this. Stateless, we call it packet filtering fundamentals. We can talk about the packet filtering fundamental because no state is getting captured anywhere and the same thing is happening. So whatever the description I have given on the packet filtering, you can talk on the stateless. So that is the one thing. All right, I hope this fundamental is got clear. Now I just want to talk about what approach we need to take when we deal with any sort of troubleshooting issues, right? Whenever we talk about delivering the troubleshooting in terms of the networking, in terms of the firewalling, whatever it is, whenever you want to do the troubleshooting, what approach you need to follow. Consider always we have the TCP/IP and the OSI layer model. So whenever I do the troubleshooting, I generally follow this approach. So if I talk about the layers, in OSI model we have 7 levels: 7, 6, 5, 4, 3, 2, 1. And when we talk about from the 1 to the 7, the first layer is your physical layer, next is your data link layer, third layer is your network layer, fourth one is your transport layer, fifth one is your session layer, sixth one is your presentation layer, and the last one is your application layer, right? So always think, guys, whenever we talk about the troubleshooting, keep this model in your mind, and everything is in this model only. Consider whenever we set up any new device, we need to have a cables, we need to have a racks, we need to have those appliances, we need to have those connectivity, we need to have those cables, we need to have those power supply. Everything related to that is handled by the physical layer, right? So you can keep all those troubleshooting under the physical layer. So whenever you talk about any sort of issue, you need to think about whether the physical connectivity is there. Is the connection what we are going to troubleshoot is physically connected well? There is no issue at the connectivity, at the cabling, at the power supply. You need to check that thing first, guys. That is a very important part, and this is how the approach usually you need to follow whenever you talk about any sort of troubleshooting. Number one, you have to check physical connectivity and the physical layer things. You can refer any definition which is available over the internet, what physical layers contain and what other things are there. This is the first way of the troubleshooting. Next, data link layer. Data link layer is more of your MAC address, your data link connectivities and everything. So whenever the physical connectivity you confirm everything looks good, you have to come to the data link layer and you have to think about the MAC address, whether you have learning the ARP entries, you are learning whatever the communication is coming from your network devices towards your switch, and those capturing is already present into your data link layer. So here you talk about the MAC address, whether you will see whatever devices are connected to your network, whether we are learning their MAC or it's not giving those definitions into your output. Generally, sometimes due to the one or the other reason, due to the power supply issue or some other things, the MAC learning is get stopped, and the processing is not happening at the data link layer, and generally we don't see that. You have to see this, whether the MAC is learning, everything is there, and then you need to move to the network layer. The network layer is more of your IP addresses, layer 3 devices like layer 3 switches, routers, layer 3 firewalls, packet filtering firewalls. So whenever you talk about any sort of communication which is getting dropped at the network layer, you need to check into your firewall. So network layer troubleshooting will help you to understand whether that packet is reaching to your firewall and is getting dropped or is getting rejected. What happening at the network layer. You have an NATing in place, you have the DNS configuration in place. Whatever the configuration related to the networking, you have to think on this layer and do the troubleshooting accordingly. The next is your transport layer. You have a TCP-IP model and TCP-IP TCP-IP ports. So whether the ports which we are talking about, which we need to be in a communication, those ports are getting allowed or those are getting denied. The port communication is properly provided. Those things you have to think about. Talk about the transport layer. Session layers, when you creating any sessions with any sort of applications, whether the session configuration is happening well, user authentication using the session is happening well. So whatever related to the session things, you have to think and do the understanding and troubleshooting with respect to the session layer. Likewise, the session layer presentation layer is combined. You have to think, if you are talking about any sort of sessions, whether you're reaching to those GUI output via those sessions, you have to think on this. And last is your application layer. So whatever the application you have configured, whether those application is giving you right output, whether you're reaching out whatever the display you need to see on the screen via the application things, you will think about the application. This is the limited definition what I have given, because there is a lot of issues and a lot of terms we can use here in this troubleshooting mode, because physical to the application layer, and if you talk about the different scenarios in the networking world, you will be having a lot of things, lot of different scenarios, lot of different things. But generally this approach, if you keep in your mind and you just go through the definition what this layers contains, and you will be able to deliver the troubleshooting work well. This approach generally I follow, and I try to see the problem in this way. Whatever, if I know the problem, okay, it's a transport layer problem, but I generally don't jump into that transport layer or the network layer. I generally try to stick my approach in this way, so that the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer things get cleared, and I just note down those things and put into the the snow ticket notes and the observations. Sometimes in delivering the networking work, you need to give the root cause analysis. So having this approach in place and adapting the details accordingly will help you to give those root cause analysis well, and your management will be happy that this approach is followed, and the guy who's dealing with this work having all these details in place, and he has all those understanding well. So this is the approach you need to follow when you do the troubleshooting. All right, so this is generally also I'll follow the approach. Now let's talk about some important things when we talk about the firewalling. Generally nowadays the firewalls whichever we have in the market, they all are the stateful inspection firewalls and application layer firewalls. So when I talk about the checkpoint firewall is more of your stateful packet inspection firewall plus delivering the application layer work greatly. Likewise, the Palo Alto have more intense inclined towards the delivering the application layer processing and the security. Likewise, in a Cisco world, FortiGate world, and the Sonic wall and all those world, they have a different varieties and different features offerings. based on your requirements. So it's up to you how you can deal with these things. I hope this video find you informative, or you feel this video is informative. So guys, please like this video, give me thumbs up, comment me if you found any details informative. So guys, thanks for watching this video and have a wonderful day.